Hey everyone, Michael Unger here from the MacMillan Space Centre. I am here in my office located on the overcast but very busy spring break day on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. And we're here for another edition of Ask an Astronomer. So let's bring in our trusted astronomer, Marley. Hey Marley, how's it going?
Hi, I'm good. I was enjoying the sunshine until it became a bit overcast, but I'm well.
And welcome to all of you that are watching. If you're in YouTube, you know how this goes. We got a 30-minute show. You can ask any question you like. We've got some hot topics that we're going to present to you. Put your questions into the chat. And if you're watching on Telesoptic, come on into YouTube. We are here every second Thursday at 2 p.m. Pacific time. So Marley, lots of fun stories to get to. Lots of fun Canadian-related things, a lot of Martian-related things. Let's start off with a rocket that we have been anticipating for a long time now.
Yes, this rocket has been a long time coming. It's been delayed. In fact, the whole program's been delayed and it took a while to build it, but it is the Space Launch System, which, whoa, what happened there? My computer just stopped. Can you still see it?
I can, yeah.
Okay, perfect. Oh, it doesn't want to go to the next slide, but that's okay. We'll just do it the old school way. So the Space Launch System, which is the rocket that'll be used for the Artemis missions, finally completed its rollout. So what this is they attached the Orion capsule, which will be the spacecraft that will go around the moon, to the very top of the rocket, the SLS, and they rolled it out to the launch tower. Now they're not going to launch it right away, but getting it there was a journey. It took 10 hours and 28 minutes to move it around. They were not going very fast because the thing weighs 3.5 million pounds or something like that when it's fully fueled. So it's a huge rocket comparable to the Saturn V rocket in terms of height and lifting capabilities. And so now what they are doing, now that the rocket's there at the launch tower, they are checking out the systems on the launch pad now that everything's assembled and hooked up properly.
So the SLS, which you just said, is comparable in size to the Apollo rocket. We actually have one of the boosters, the J2 boosters, in our gallery space, if you've ever been in our gallery space. But of course, we haven't had a need for something this big before. Why do we need such big rockets to get where we're going?
It takes a lot to get to the moon. If we're sending people and cargo and food, all of that adds weight and mass to what we're sending, right? And so it's not like going to the International Space Station. It's a short journey. It's like a 4-day journey, give or take, to get to the moon. And it's not in a straight line either. You orbit around the Earth and then you kind of slingshot your way to the moon, and then you got to orbit the moon a little bit. And so it takes a lot of power to generate, a lot of fuel to generate that thrust needed to get you out into and have the speed necessary to get you to the moon.
Right. So when we're talking about SLS and even Apollo, these are really moon-based rockets that we're building here. These are built specifically to get humans or cargo to the moon.
To the moon, yeah. It's not for a little jaunt in the lower Earth atmosphere. It is for the moon. It's quite an impressive move.
Awesome. And so for all you folks out there, you're probably going to hear a lot of terms. So we're talking about SLS, which is Space Launch System. And of course, we're also talking about the capsule. We're also talking about Artemis. So maybe break down what all of those words and titles mean for us.
So Artemis is the program. It's the sister to Apollo program, right? It's the newest moon program. Artemis 1 is the mission or the section of the program that we're currently in, which is sending an uncrewed Orion capsule around the moon. So the Orion capsule is the bit on the very, very top, just underneath this spiky thing on the rocket. And that is where, cargo would be, but more importantly, people. So the astronauts would be inside the Orion crew capsule. And then SLS is the rest of the rocket, the Space Launch System. It's the system that's built to get the Orion capsule on its way.
Awesome. So this is super exciting. So this is going to be the first test. I'm not going to have any humans on this first test as things go with tests. You want to be safe. So this one is, what kind of time am I looking at here? I was thinking maybe June, I think I heard.
Yeah, so it's been pushed back a couple times with COVID and other problems that arose, budgeting issues, but we've completed the rollout when now we're on to system testing. So they're doing battery of tests on the entire system. And then next up in early April is the wet dress rehearsal. And then launch will be in the summertime. Some sources say, no earlier than May 2022, but my bet is on June. I'm assuming they're not going to launch it in May. I think it'll be pushed back again to sometime in June or even later. But I'll be very surprised if they launch it in May. That'd be a very fun surprise, but I don't think it'll happen.
Yeah, and of course, I mentioned off the top that this is a Canadian initiative as well. So these next two big topics we're going to talk about do have Canadian connections. So what is the Canadian Space Agency? As Canadians, we are taxpayers if we live in this country. We're also supporting these missions. So what is our involvement with Artemis and SLS and Orion?
So Canada's involvement is largely a robotic involvement. So you may have heard of the Lunar Gateway that's coming up that will be built to orbit the moon. And so Canada has a large role in getting that built, building the Canadarm3. We're really good at one thing and we kind of stick with it. The Canadarms we love. And so we're going to be building another Canadarm3 that will help assemble the Lunar Gateway. And in exchange for that, a Canadian astronaut has a guaranteed seat on the Artemis 2 mission. So the Artemis 2 mission is sending astronauts on a course around the moon, not landing, but going around. And a Canadian astronaut has a guaranteed seat on that flight. So that is what we get in exchange for providing robotics and other technological aspects to the mission.
We love our robot arms here in Canada. We put it on our money. They're just so handy when you're out there in space. Why use human arms when you can have a robot arm, right?
It's a great arm. And Dexter too. They're just great little robots. I love them. They do so much work.
So let's move on. So you also mentioned wet dress rehearsals. What exactly is that?
So a wet dress rehearsal is essentially everything but liftoff. So they are going to practice the launch countdown, go through all the motions. They're going to fuel the entire rocket with liquid hydrogen and liquid oxygen. The fueling effort takes 8 hours to get the whole thing filled with enough fuel. So that'll happen over the course of a day. And then the entire wet dress rehearsal takes 2 days. So they will go through all the motions, counting down, and practice what's called scrubbing a launch, which means when you have to preemptively cancel the launch or suddenly cancel the launch. And this has happened before because of weather conditions, changes in weather, an error signal coming up. They'll just stop the launch entirely. So they're going to do that, count all the way down till T-minus 10 seconds, scrub the launch so the rocket won't actually ignite or fire anything. And then they'll go through a process known as detanking, which is emptying out all the fuel. And they do this to test to see where the rocket's at through all stages of launch, because there's a lot of things that have to happen as the launch countdown begins. Different things have to ignite at different times, and the arms have to let go on the tower, let go of the rocket, all these different things, and they have to happen in a specific sequence. And if anything in that sequence is messed up, it could be mission end for the mission. It could destroy the rocket or otherwise, have a bad outcome. And so they go through all of this to practice essentially before starting the actual liftoff. They'll also have another test, which is like a fire test where they ignite it. But I haven't seen an announcement as to when that will be, but it'll be after wet dress rehearsal and before liftoff.
Excellent. And a lot of these processes have been in place, for many years. We have seen, some disasters, looking back at the Challenger disaster and Discovery, but all of those setbacks have all given us, more information, what we need to make sure that these launches are successful for today and for the future.
Yeah, there's always something to learn from failure, and a bad mission outcome, but you want to avoid having one, if that makes sense. It's terrible if you have one, but you can learn a lot from those, but you want to anticipate the problems before they become problems. And so that's kind of what this wet dress helps with.
Okay, well, we're going to be looking forward to this, of course, over the next several months. I just led a group this morning lifting off some rockets in our backyard in Vanier Park here. So very excited. We'll be maybe doing some more of talking about this on Ask an Astronomer in future episodes, as well, maybe doing some events. But let's move on to another topic that we've been talking a lot about over the past couple of months. It's finally out there in L2. We're talking about JWST. Marley's favorite telescope that is finally ready to start looking out into the universe.
It is. Well, It's really good. So this is a alignment selfie from the NIRCam instrument. And in the past episodes, I think I showed a picture of the alignment selfie, and only one of the hexagons was illuminated. In this one, all of them are illuminated, and you can see the support struts, those lines on the mirrors. Those actually come out and they hold the secondary mirror where that black hexagon is. And so it's just great. It's working. It's illuminated. They went through, it's like a 7-step process, and they've completed step 6 of getting all of the mirrors aligned properly to generate an image. And they ended up getting this alignment evaluation image. So this is not a scientific image by really any means. They didn't collect any scientific data on it. It was for calibration and alignment purposes. But it is a wonderful image because when I watched their press conference about it and the members of the team were discussing it, they are as aligned, what telescope is as aligned as the laws of physics will allow them to be. So it is the best that we're going to get with the telescope, which is great because there's, the best possible we could work with, and then there's the best we could ever get. And having the best we could ever get is a great success for the team. And what's interesting about the image is that the bright star is in the center there, and those lines coming out of it are just remnants from the image processing and how the image is taken on the telescope. But all of the dots in the background are faint stars and galaxies. And you can see the galaxies, the more very oval ones in the background. And so this really just shows how sensitive Webb is as a telescope, that even, I think this image only looked for 35 minutes, only collected 35 minutes worth of light, which is like, okay, that sounds like a long time, but it's not in telescope time.
Yeah.
And still able to get, these faint galaxies in the background is really, really cool.
Yeah, and I thought I had to wait a long time when I was taking a picture of a couple of my friends. We were in a dark room, and it took like 5 seconds for they get much light into the camera in order to take a proper picture. But you're talking about 35 minutes. Any photographers out there know what we're talking about. Long exposure.
Extremely, yeah.
So this is a really cool image, Marley. Of course, it's not as spectacular as, some of the Hubble images that we've gotten in the past, a very historic image. This will definitely go down in the history books. Now, I actually had a question recently by a visitor who probably saw some of these pictures in our gallery space. I'm going to put you on the spot here, Marley, see if you can answer this one, because I kind of gave an answer. I wasn't completely satisfied with my answer. So when you look at this photograph and you see how the star, makes those beautiful lines. When we draw pictures of stars, we often have, little like 7 points, right? And we've got, in this one, at least 6 main points, and some few smaller ones. Why does that happen? Is it because of our eyes, or is that because of the way the telescope is taking the picture?
So the 6 points that you're seeing, the 6 major points, come from the telescope being made out of hexagons. Right. This was a question that was asked at the press conference they gave about the image, and it is due to how the light is bouncing around on the primary mirrors, entering the NIRCam instrument. And because it is all hexagons, you end up getting this perfect 6-pointed image. So this is not what the star would look like to our eyes necessarily. It's like an artifact of how the light has been moved into the instrument field of view. So it's just what happens. It happens even in like the Hubble telescope images. The foreground stars have like the 4 points on them. It's just a consequence of the light being bounced around into the instrument. Okay,
so that makes a bit more sense. So then, when we're using the telescope here at the Space Center, and we're also looking at stars, and it starts to do that, that's because of the mirror on our telescope.
The mirror on the telescope, it's called like aberration. I think even like I have an astigmatism in my eyes, and so sometimes light on telephone or like the light posts have spikes on them, and it's just how the light is interacting with the lens in my eye. Like it has to do with how the light gets bounced around.
Yeah. Okay. Very cool. So this is what we're here. Like a personal astronomer, Marley. It's great to have such a great resource. Great for all of you folks, hopefully, that are joining here. If you have any questions like that you've always been curious about, throw them into the chat. We'll get to them. So let's talk a little bit more about our other favorite topic of the year, probably your favorite. mission that is not associated with the moon or the Earth. I'm going to say it is Perseverance and Ingenuity on Mars. Am I correct with that, Marley?
Well, it's not. It's I guess you could say it's one of my favorite current missions. My favorite mission ever is the Cassini mission. I love that mission. But this is. I do love Perseverance. I have a soft spot for it, Perseverance for sure. And it's a little helicopter. I do want to say that this image is not actually red. They added the red filter to it. So you could see it better. So it's not actually red at all.
So it was the red sun.
Red was added. But here is Perseverance and Ingenuity update. They are on the move. So this is a screen grab from NASA's interactive map that you can, it gives the real-time data of where Perseverance is on Mars and shows its route and where it's taken sample collection data. And it also shows Ingenuity. The yellow line is what I have added, which is where Perseverance is now headed. So Perseverance has completed its primary science mission, and now it is on to its secondary mission, heading towards the Three Forks and the entry of the delta in the Jezero crater. So the first science campaign started, at the Octavia E. Butler landing site, and then going down into the Setia region, collecting samples along the way. And then they kind of backtracked. It went back to the landing site. Now it's kind of on its way, going around these craters and rocks up and around to the Three Forks region, with Ingenuity following along, because Ingenuity's mission length just got extended through September. So it is going to continue helping Perseverance chart out routes that it could take, as well as getting images of the Martian surface, not great ones, usually just used for Perseverance to help it's moving along, and also collecting data on how things fly in the Martian atmosphere, which is really, really exciting considering that Ingenuity was only supposed to fly a handful of times, and now it's just completed its 22nd flight. So that little rotorcopter is really, really doing quite well for itself up there. So I'm very proud of it and the team.
Yeah. This is amazing because, originally, as you said, this was just a test. They were just wanted to make sure that it actually could fly on Mars. And that was a success, did a bunch of other tests. But now it's hitting this next phase of its mission where it's actually working together with Perseverance on its mission. This is incredible. I know that they probably had this, in the back of their minds. Like, do they actually plan for this? Like maybe not a first priority or a second priority, but somewhere down the line, did they perhaps know that this is the stage they would be at with Ingenuity?
It's always a possibility. Like they had, if it, succeeded all of its tests, part of it could go on to like an operations mission to help Perseverance along. But in that, there was always the caveat that if it ever hindered Perseverance's mission, it was to be stopped. Like Perseverance is the main mission. Ingenuity is kind of a bonus that's been tagging along. But because it is working so well, they're like, we might as well just use it until it stops working, which really is what kind of NASA, JPL, and a lot of space science missions are about. They will use the technology they've built until they run it into the ground. Like literally, like if you looked at Curiosity's wheels recently, like they are just using it until it stops. So I'm not surprised that they ended up using Ingenuity, but I'm very happy that it never impeded Perseverance's abilities to do its job.
Yeah, so this is so great. So if anyone has been coming to the Space Center over this past week during spring break, and spring break's not over, still got another few days, a weekend to go, we've been building helicopters in our gallery space. So if you do come, you get to do that. But there was a challenge, of course, like flying a helicopter on Mars is not the same as flying a helicopter on Earth. So what are the main differences and challenges that Ingenuity is trying to overcome?
Well, what's interesting with Ingenuity is they couldn't actually test it perfectly on Earth because we could not recreate a perfect Martian environment on Earth, right? Mars has less gravity than Earth, and it also has a thinner atmosphere. And the less gravity part really kind of works in our favor, right? Not as much as the force that you have to fight against to generate thrust and to get yourself off the ground, generate lift. But the problem with that is the thinner atmosphere comes into play. The thin atmosphere makes it very, very hard to generate lift. The way aerodynamics and aerodynamic forces work, it's very, very hard to do that in a thin atmosphere. And so Ingenuity is very, very small, partly partly because of that, also because it had to be packaged alongside Perseverance. It had to fit in its belly. So it's very small, but then its rotors are very, very long. They're like a meter, just over a meter long, each one of its full rotors. And they have to be that big to help be able to spin and get enough air moving to be able to lift itself up. They're also very angled. If you look at the blades of Ingenuity, they're like at a very severe angle to slice through the air to start generating that lift force to be able to get itself up. And they spin very, very fast. Like a regular helicopter, like a passenger helicopter on Earth, its blades spin at something like 450 revolutions per minute. So like in a minute, it'll spin 450 times. Ingenuity, even though it's much smaller and it has bigger, has to spin 2,700 times per minute to be able to generate the same amount of lift to move. So, the gravity part is great, but that thin atmosphere is very, very difficult to deal with.
Okay. Well, in a few minutes, I'm going to go back down to the gallery space. I'm going to get the kids to maybe we'll put a little bit more angle because we want to make it more Martian-like. We got a lot of helicopters spinning around. It's actually kind of dangerous down there. I'm just joking. It's safe down there, but we're building a lot of helicopters.
They're just paper.
That's right. They're just paper, not actual blades. So what's this video that we're about to watch here?
This is a video because I like saying like, we're going to Three Forks doesn't really mean anything because we've just kind of named things on Mars the way we want to. So this is showing Perseverance's path, where it will go. Ingenuity doesn't follow the exact same path. It kind of cuts across places. And kind of in context of where this location is in the Jezero crater. So as it zooms out, we see that we're right near the delta. And so astronomers and planetary geologists and other scientists are pretty confident that at this place in the Jezero crater, this delta is where water once ran through. And so to quote one of the scientists is that Perseverance is hightailing it over to this area. It won't really be taking any samples along its journey. It's going to wait to take samples until it reaches the river delta, because the river delta spot is a place where they anticipate and kind of hope to find much more evidence of if there was life on Mars. If there was life on Mars, they're pretty confident it would be in this area in particular. So this is kind of just the bigger context of where this Three Forks area is. It's leading into the river delta.
Yeah, interesting. And it actually is called a delta for a specific reason too. I actually grew up in North Delta, which is not too far away from here, but they also called that because of its specific location here in the Lower Mainland, because it's sort of at the mouth of a river, right? And that's why they named this area Delta?
Yeah, because it's a delta. Yeah, like I don't know, like it is like
it is a delta.
It is a delta
because
so
it is a delta.
It's a delta, yeah.
So of course there isn't no flowing water there right now, but the hope is that if there was actual flowing water there in its past, it could have some of those nutrients or perhaps signs of life still underneath the soil.
In the rock, yeah, embedded in the rock. So in the soil, in the regolith. So they'll be heading over there right quick to take a look. So
okay. Very exciting. Well, this is we're also going to be looking forward to this as well as these other missions. So as we get into our next month, we're almost at April, if you can believe it, of 2022.
Wow.
This month we've been obviously talking a lot about Mars and propulsion. Spring break is happening currently at the Space Center right now. Next month we've got another evening event coming at you on April 21st. We are going to go to the other world that we are hoping to get to, and that is Venus. We are going to be focused on Venus, and we have an event. We have Megan Russell from the Planetary Institute, who does a lot of work on Venus. We have 3 new missions to look forward to over the next several years. We haven't really talked a lot about Venus. There hasn't been a lot of NASA focus on Venus recently, but we as an organization at Space Center for the next month, we're going to focus on Venus. So we'll maybe give a preview over the next couple Ask Astronomers, as well as that event on April 21st. How excited are you for these Venus missions, Marley?
I'm pretty excited. I don't know. It's hard to think about because they're not going to launch until the 2030s. And so there's many more things happening before them. But I am excited that Venus is kind of coming back into the conversation as an interesting planet, because I think it always kind of got pushed out because it was so hot and it was like, oh, nothing could live there. Let's just move on. But it's still worth studying. It's still a very interesting planet. There's not a planet in our solar system like it. It's very unique. So why not study it, figure out why it ended up the way it did?
Absolutely. And then, of course, in May, we have a couple events. We've got May the 4th. Do you know what we're doing on May the 4th, Marley?
No idea. What could it possibly be? Is it perhaps Star Wars related?
Well, I know that you know, because I know you're a Star Wars fan, and I actually just confirmed with ILM, the Industrial Light and Magic, who have headquarters here in Vancouver, that they're going to do an event with us on May the 4th. And so you're going to actually learn a really cool stuff about how they take, the script and actually work with it to create, special effects images that you eventually see in the movie. We're actually going to focus on The Last Jedi for that event. So they're going to sort of take us through from script to screen, the process that they undertook on May the 4th. So that's going to be an online event on May the 4th. And May the 5th, Revenge of the 5th, we're going to have an in-person event. And we're actually going to have members of the 501 Legion, who are local members of the community that have put work with support from Lucasfilms on their costumes, stormtroopers, Boba Fett's, Mandalorians. You probably know there's going to be some Mandalorians.
Oh, definitely.
They're going to show up. So that's going to be an in-person event on May the 5th. So that's going to be really exciting. Marley is going to do a show here in the planetarium on the theme of galaxies far, far away. And I'm going to guess maybe JWST is going to maybe play a part in that show. What do you think?
That telescope usually weasels its way in somehow, especially when we're talking about galaxies. That's for sure. Yeah.
Awesome. And Wet Coast, who just commented, said May 4th is their mom's birthday. But Marley, you also have some announcements as well. I think you want to do a shout out. Do you close down your?
No, I still have it. It's just I'm gonna have to do the silly thing where I share and then click back. I'm at home right now, and so I don't have my dual monitor set up, but I have to click. I wanted to shout out my grandparents who watch every week. It's their 60th wedding anniversary on the 31st of March. So happy 60th wedding anniversary, you two. You could always still get divorced if you really want, but 60 years is a very long time. That's a running joke. It's fine. But I love you both very, very much. And I hope you have a very good day on the 31st. And I love you both. Mwah, mwah, mwah.
Oh, wonderful. So a happy anniversary to both of you. We actually did get one more question just as we wrap up the show. We got 3 more minutes. So if you do have some questions, get them in there now. Julie J asks, are we going to examine Europa in the future?
Europa, yes. I think that's one of the moons that is going to be done in the Jupiter Icy Moons missions by the European Space Agency. I'm not mixing up my moons, I don't think. No, it will be studied not independently on its own, but as a part of that larger mission done by the European Space Agency. It will be going to study Jupiter's moons, Europa's of particular interest because of that under ice ocean that it's got going on, that we think it's got. So that will be something that will be coming in the future. Yeah, for sure.
So we have 2 on the books. There's the NASA Europa Clipper and the European Space Agency JUICE mission. The Jupiter Icy Moon Explorer.
Yeah, that's such a fun acronym. But yes, it will be Explorer. But I think JUICE doesn't launch until 2024, and then it takes a while to get there. But it's coming. It's coming.
Yeah, so both of those missions, of course, we're not going to be able to get under the ocean in these missions. We're just going to start to explore, I don't think either of them are orbiting. Maybe the Europa Clipper is going to orbit around, but they're doing flybys for sure, right?
Yeah, JUICE will fly by for sure. I think it'll enter an orbit around a couple of them and then leave, but none of them are permanently, JUICE isn't permanently staying around any of them, I don't think.
Right. Excellent. Well, folks, that's it for this edition of Ask an Astronomer. Like I said, we are here every second Thursday, which means our next one is going to be on April the 7th. Like I said, April is coming. It's also the start of spring. We just had equinox. We didn't even talk about equinox, but that happened last week.
It's old news, equinox.
Yeah. We are in balance. We have equal day and equal night. So get on out there and enjoy the more sunshine, and we will see you in 2 weeks. Take care, everyone.
Bye, everybody.